Today we're going to do an activity in groups where we're going to find the velocity of a motorized toy car. Now, it's a relatively simple procedure, a relatively simple analysis. The reason we're going to do this activity today is A, to make sure that you know how to plot graphs, interpret graphs, and collect data, but B, to give you a nice, simple, first marked activity to submit electronically, so that when we do something that's more complicated, again, we've already gone through that process. Here's how it's going to work. We're going to break you up into groups of around 8, although we'll have to have a couple groups of 7, I suppose, just because of the number of people here today. Each group of 7 or 8 is going to choose one person to launch the car. So that one person is going to launch this little toy car right here, simply by flipping on the switch. We're going to have various stations 1 meter apart. Little pieces of tape on the floor, 1 meter apart. We're going to have all the other members of the group standing at every station except 0 meters. Person number 1 will stand at station 1. Person number 2 will be at 2 meters. Person number 3 will be at 3 meters, and so on. Each of those people will, with their phones or with their stopwatches or whatever it is that you use to measure time, will measure the time that it takes the car to go from here to their station. So you start your timer when the car crosses the starting line. You stop your timer when the car passes your line. So Ryan's going to be, let's say, at station number 1. Okay, him and his group can figure out which station he's at, but let's say he's at number 1. He's going to start his stopwatch now. He's going to stop it now when the car gets to there. But on the other hand, Bart, who's at station 2, starts his timer at exactly the same time, doesn't stop it until the car gets to station 2, and so on and so on and so on. So what you're going to end up having is a data table when everybody comes back to the class and puts their data together that looks something like this. First column will be time. Second column will be position. The time will be the times that everybody in your group collects. The positions will be 1 meter, 2 meter, 3 meters, 4 meters, and so on. Does that make sense? Now, quick question. Karen, then I'll answer your question, okay? No, I'll get your question 1 second here, okay? Once we get back into the classroom, we're going to plot a graph with this, but we're going to plot a graph electronically, and I'll show you how to do that after we get back in the classroom. I will tell you right now, on that graph, your x-axis will be time, and your y-axis will be position. What does that tell you about which is the manipulated variable and which is the responding variable? Yep. Time's the manipulated variable. And that doesn't seem to make sense to people sometimes. The manipulated variable is the time. That's the variable that we're changing. No, we're not. We're changing the position, right? No, we're not. Think about this. Where the car is a function of how long it's traveled. So although we're not controlling how much time the car is traveling for, how much time the car is traveling for does determine where the car is. Does that make sense? So time will be the manipulated variable. Position will be the responding variable. What would the title of this graph be, by the way? Same as it's always been, right? Y-axis versus x-axis, so responding versus manipulated, or in this case, it would be position versus time. Or you could say position dash time, or you could say position as a function of time. What shape of this graph would you expect to get from your data? We know this. What's the motion of this car probably going to be? Is it going to accelerate? Is it going to go backwards? Is it going to be a constant velocity? probably a constant velocity in the forward direction, right? We should end up getting more or less a straight line. Now, what's going to happen is that your data points won't be a perfect straight line. We're going to draw what we call a line of best fit, which is going to approximate what the straight line should be. And then we're going to get the slope of that straight line, or just use v equals delta d over delta t to get the speed. Ultimately, we're going to get the speed of the car, right? How fast is this car moving? We're going to get that by graphing it, right? Carrie, you had a question? That's a good question. That's a good question. When would we stop the stopwatch? When the front of the car goes by it or when the back of the car goes by it? You guys decide that as a group. It doesn't matter as long as you're consistent as a group. If everybody in the group does exactly the same thing. Okay, make sense? So if you guys choose the front of the car, that's probably what you'll do is the front of the car, but it doesn't really matter. Okay? Then make sure that you start it when the front of the car passes the 0 mark, and make sure you stop it when the front of the car passes 0 mark. As long as you're consistent, it doesn't matter. Times will be the same. Right? Any questions? All right, we'll pause this here right now. Okay, we'll organize you in your groups. We'll go out into the hallway and get this set up. And then we'll come back. We'll press record again, and I'll show you how to deal with plotting the graph and submitting this thing electronically. Okay? All right, now that everybody's got their data for the activity collected, I want you to log onto the Chromebooks. I want you to go to classroom.google.com. It should take you to a screen that looks almost like this, except that you won't see the Physics 30 icon there. You'll just see the Physics 20 icon. Click on Physics 20, because that's what class you're in. You're going to see one activity, one assignment listed here. It's called Toy Car Activity. It's the one you just did. Notice when you scroll down, there's a few instructions there. Not much. You don't need a whole lot of instructions for this. It just says for this activity, plot a graph with best fit line and slope in Google Sheets for both trials. Copy and paste those graphs into a Google Doc. Make sure you include materials, procedure, a data table, and your graph, I should say, and your graphs in the Google Doc that you submit. So let me show you how to plot a graph here right now, okay? I'm going to open this activity because, of course, this is the activity that I want to work on here in the next 15 and then submit. So I'm going to click on open. And now I have to create something. Oftentimes you'll just create a document, but this time, since you have to plot a graph, you will first create a spreadsheet. It's going to look like Microsoft Excel. Just works a little bit differently, that's all. So toy car activity, okay, there's my name, Student Dickie, Google Sheets. Let's click on that. And now let's enter some data. Okay, for trial number 1, I'm going to say time in seconds. I'm going to say position in meters. My times were, oh man, were my times ever convenient here? Oops, they're non-existent, because that's what they are. Here we are. 1, 2. My times were 1, 2, 3, 4, 5, 6, 7, 8, 9 seconds. Perfect. Excellent times. My positions were 2, 4, 6, 8, 10, 12, 14, 16, 18 meters. Perfect. Okay, I get excellent data here. Your data probably won't be quite so neat. Now I'm going to go to plot this graph. Okay? Watch very carefully. Let's highlight my data. Okay? Let's insert a chart. I'll pause there. Okay? I want you to type in your data, highlight that data, and then go insert chart. I'll pause until you guys are caught up to me. Now that I think most of us are there, I want to show you how to actually plot this graph. We've highlighted the data. We've clicked insert chart. Now what I want you to do is click chart at the top of the page here. And I want you to click scatter plot. So chart in the toolbar, then scatter plot. You have to select one of 2 scatter plots right here. Okay, scatter chart 1 or bubble chart. Let's click the scatter chart. There's my graph. So let's make sure that everybody gets to this point. This is where you were. You're clicking charts, scatter plot, and then you're clicking the first scatter plot right here. Don't do anything. Don't click insert. Don't do anything else right now until everybody's caught up to us, okay? We'll pause it, and then we'll come back to it once everybody's caught up. All right, now that everybody's at this step, take a look at this graph. Notice it's missing a couple important things. Number one, it's missing a title. Number two, it's missing axes labels. So let's go into customize before we insert the graph. Let's go into customize. Let's title our graph. Position versus time for blue car, or whatever the case may be. Position versus time for red car, whatever. But not only do we need that title, we also need our axes labeled. So scroll down to where it says axis in red. Your horizontal axis needs to be titled time in seconds. Now, this is what bothered me when I first was playing with this here a few weeks ago. There's not a place to enter the vertical axis. You have to click on this drop-down menu and go to left vertical. Now let's click on position. So my horizontal axis, I've labeled as time. My left vertical axis is position. Now we're getting there. We're almost done. We've got our axes labeled. We've got a nice title. Good. What we don't have, though, is the slope of this graph. Google Sheets will calculate it for you. Let's draw a trend line. So scroll all the way down to where it says trend line. It says none in the drop-down bar. Click on linear, because it looks like it should be a straight line. Scroll down a little bit further. The last thing you have to do here, before you insert this, is beside label, click use equation. Now notice in the top right-hand corner of this graph, an equation pops up in the form of y equals mx plus b. In this case, y is equal to 2x plus 0. The slope of this graph is m. The slope of this graph is 2. Got it? So that's the speed of my blue car. It's 2 meters per second. Now I'm going to insert this graph. You can see it in my spreadsheet here now. Now what I have to do is go back and create a document, because the document is what I'm going to submit. So I go back to the classroom, create the document. It's going to pop up in just a second here. Okay, there it is. The document's there. I'm going to click on that document. I'm going to go back to my spreadsheet. I'm going to copy that spreadsheet, copy that chart, I should say. Go back into my document. I'm going to right-click it. Right-clicking, by the way, on Chromebooks is just tap the touchpad with 2 fingers. Okay, tap it with 2 fingers. That's right-click. And then I'm going to click paste. You could also go Control-V. That will also paste it. There's my graph in a Google Doc. Now, what else do I need here? Well, I needed materials. I needed a procedure. Make sure when you're doing a procedure that you number the steps. Step 1, did something. Step 2, did something else, and so on. I need data. Data? You mean I have to type in that data table all again? No. Let's go back to your spreadsheet. Let's highlight the entire table, including the names of the axes. Let's right-click it, or 2-finger touch the touchpad. Let's copy that. Let's go back into here, and let's paste it. So I've got my data table copied over. Then I'm going to put my analysis in, which is my graph. Now, you're going to have two data tables, one for the blue car, one for the red car. Make sure you label it. Let's say blue car. Okay. Underneath that, you'll have another data table for the red car. For the analysis, you're going to have a graph for position versus time for the blue car, and then another graph, position versus time for the red car. And again, up here in the top right-hand corner, right here, y equals mx plus b. 2 is m. 2 is my slope. So the speed of that car would be 2 meters per second. Bart? No? Okay. So you might have to go, just go edit, paste then. Okay. Edit, paste. Guys, if right-clicking with two fingers isn't working there, then just go edit and then paste. Edit, copy, edit, paste. The old-fashioned way. So this is your lab. Materials, list them. Procedure, list them and number them. Data, which includes two data tables, and your analysis, which includes two graphs with titles, with axes, with lines of best fit, and with equations that display the slope. Once you're done that, you don't have to save it because it says all changes saved in Drive. Once you're done your activity, all you're going to do is go back to here to the classroom, and you're going to click Turn In. You're going to submit the activity to me. Now notice the due date is tomorrow. Okay. I anticipated that you would get this done in class today. It doesn't look like we will. Pop in during scheduled help. Stick around during scheduled help. Keep working on it. Okay. Come in at lunchtime, whatever. Okay. What we'll do though, because we didn't finish it in class here, I'll actually change on my screen the due date to Thursday. That gives us 2 days so that you can come in during scheduled help tomorrow if you can't today, if it doesn't work today. Keep in mind you can also work on it at home on your own computers. Right? Any questions? Notice one more thing though, guys. One more thing that I've added kind of midstream as you guys are working. If you go to that classroom again and you see the toy car activity, there's two things attached that weren't attached before. The first document is the instructions for all this process of submitting it. The second document is if you forget how to plot the graph, there's instructions for how to plot the graph and add the trend line. Okay? You can also come back and watch that podcast if you want, whatever happens to work for you. All right, that's it.